Okay, so I posted some practice problems for you, and I want to go over the answers to those for ANOVA so that you have an idea of where you may have made calculation errors if you did. But this is a way for you to check your answers and then see how things are calculated. And these are the problems that we would have done in class for our practice problem day. For problem number 1, it says, a professor is curious if students spend different amounts of time preparing for different psychology courses. She randomly samples 3 students from 3 classes and asks how long they prepare for the first exam in the class. So the results here in the table are how many hours the student prepares for each test. And each of these rows represents a different student. The mean and the sum of squares are here for you. And you have a source table for ANOVAs, for all of the ANOVAs that we're going to do. One-way ANOVA, factorial ANOVA, and repeated measures ANOVA. You always have a source table that looks like this. And this is where you're going to have to fill in your answers, or what you should be able to read when you're looking at ANOVA data. Now, in our steps of hypothesis testing, the first thing that you need to do is set up your hypotheses. When you are setting up your hypotheses, you're going to have a null and an alternative hypothesis. With ANOVAs, you do an ANOVA to measure differences between groups, just like you do an independent t-test to measure differences between groups. The thing with ANOVA, though, is that you have more than 2 groups. So with t-test, you're testing group differences with 2 groups. With ANOVA, you are testing group differences with more than 2 groups. So when you set up your null hypothesis, you're going to say that there will be no differences between the 3 groups that we're looking at in this problem, or they're all equal. You could also, if you had 4 groups, you could just add right on to the end of this. For the alternative, the best case scenario for you here is to just say that at least one of the population means is different from the others. You don't want to simply say that group 1, group 2, and group 3 are unequal, because that doesn't capture all of the possibilities that you could have for an alternative hypothesis. You could have group 1 and group 2 being equal, but group 2 and group 3 being unequal, or group 1 and group 3 being unequal. So this doesn't capture enough information or all of the alternative hypotheses that you could have. So you want to say at least one of the population means is different from the others. For step 2, we find our critical value. And the first thing that you need, well, you need 2 things for a critical value. You need alpha level. We typically use a standard of 0.05 in our class. On a test, you may see different variations of that, so you want to check what alpha level you have. You also need degrees of freedom. For your degrees of freedom, you'll want to go to your source table and fill those in. So you'll see on your source table, you have between, within, and total, sum of squares, degrees of freedom, and mean square. And this is what you're going to need to calculate your F value for ANOVA. So for degrees of freedom between, you're going to need K, which is the number of categories or levels you have. And for this one, you have 3, because you have 3 different levels of class. So K minus 1 is 2. For within, you take N, which is the total number of participants you have across the groups, and you subtract out the number of categories you have. So you should have 9 total participants minus K, which is 3, equals 6. And then for total degrees of freedom, you don't actually need this to get your critical value, but you will need it for later to fill in your source table. So let's go ahead and calculate it. It's N minus 1, and N again is the total number of participants, so you have 9 here. You have 9 minus 1 equals 8. One thing that I want you to see when you're looking at this, though, is that you can check yourself. When you add up your between degrees of freedom and your within degrees of freedom, you should get total degrees of freedom. The same thing is going to happen when we calculate our sum of squares. between plus within equals total. So we've gotten our degrees of freedom. I put them in the source table, and you're going to need two values in your critical value table. You need the degrees of freedom for the denominator and the degrees of freedom for the numerator. Now, what it's talking about is in your fraction for your f values, you're going to have mean square mean square between divided by mean square within, and you're going to get an f value there. So the numerator of your fraction is between, the denominator is within. So the same thing with your degrees of freedom. This would be associated with the numerator, the 6 would be associated with the denominator. So if you go to your table and you look at degrees of freedom 2, down, all the way down to the 6 degrees of freedom for the denominator. The bold face is for alpha of 0.01. The other is alpha of 0.05. So that's the one we're looking for. You get 5.14, and that is your critical value. Then you're going to need to complete your calculation. For independent measures ANOVA, these are the formulas that you will need, and those can be found on your formula sheet. You will also need to know how to calculate G and T. You can see those are in the formulas here, but those aren't on your formula sheet, so you need to know where those numbers come from. Now, to complete our calculation, you're going to need to fill in the rest of your source table. The first thing, and I think that's the easiest to do, is within subject's sum of squares. You've already gotten degrees of freedom, so we're going to move on to sum of squares. So within subject sum of squares, you just sum up the sum of squares for each treatment or each level. I've already given those to you in your table, and I will do so on your test or your quiz. So you just add 32.67 plus 6 plus 8.67, and I have done that over here. You get 47.34. The next one that you'll need to work on is sum of squares between, and I've also calculated that, and I've gotten 8.66. Now, when you are calculating your sum of squares between, you need the sum of t squared over n, small n, minus g squared over big N. Small n is the number of participants in whichever group you're looking at, so whichever condition you're looking at. Big N is the total number of participants in your whole sample. T is the data for one particular group, and I've calculated T here for each level. So T is each raw data point added up together. 1 plus 6 plus 9 is 16. For intro psych, that's 9. For cognitive psych, it's 14. And then G, you get just by adding up these T values. So T is the sum of the data points for a condition or a level. G is the sum of all of the data points. So you can see I took 16, 9, and 14. I added those up and I got 39. Then you're going to plug those into your formula. So you have to do a sum of t squared over n for each condition that you have. So you can see I did that for statistics, intro psych, and cognitive psych. So 16 I got from here is the t. I squared that. I divided by 3, which is the number of participants for statistics. Then I moved over to intro psych. The t is 9. I squared that and divided by 3, which is the number of participants. And then I did that again for cognitive psych. The t is 14. Divide by 3. That is the part of the formula for cognitive psychology. Then I did the minus part, the minus g squared over n. So I took the g squared and then divided by the total n, which is 9. If you work that calculation out, so you should square the value and then divide by 3, square the value, divide by 3, square the value, divide by 3, square the value, divide by 3, then add these values together and subtract out the last portion. You should get 8.66. 6. The next thing we're going to calculate is total sum of squares. There is a very complicated formula in your book for this. I say don't use the formula. Remember, with degrees of freedom, if you added between, within, you got the total. You can do the same thing for sum of squares. So if you add 8.66 to 47.34, you get 56. It's as simple as that. Then the next thing we're going to move on to is the mean square between and the mean square within. You calculate those both the same way. You're going to take your sum of squares number, divide it by the degrees of freedom number, and that is going to give you the mean square. So I have done that for between and within here. And then finally, for your calculation, you are going to calculate your F value. Your F value is simply the mean square between divided by the mean square within. And if you calculate that out, you should have gotten 0.55. Step 4 for hypothesis testing is to make a decision and write an interpretation. Our calculated F value was 0.55. It is less than our critical value, which was 5.14, so we fail to reject our hypothesis, our null hypothesis. And here is an example interpretation that you could have written. Remember that you need a narrative statement about what happened with your statistics, so the students did not spend different amounts of time studying for their first test in a statistics, intro psych, or cognitive course. I put in descriptive statistics, and you should add those whenever you have the choice to do that. You should be able, if you have the raw data, you should be able to get those values. And then you should put in your APA statistics here. You have F, the degrees of freedom between and within, your calculated F value, and for this one it's P greater than 0.05 because we failed to reject. Okay, I'm going to stop here and I'll do a separate podcast for problem number 2.